I think I have
yeah, maybe we should spend a part of the class period. Yeah, well, because you always have to write a little bit about what you're doing.
And then if you have an Artenian ring, using super strong hand. And then a non-zero which it turns out that the first person of
if I can have your attention, please. I am very excited to present someone who's been a guest and a visiting scholar and turned into a friend this year, who actually accompanied me to Cracker Barrel for lunch today. So this is Dr. Xiaoying Nie, who is visiting us to learn more about using technology in the mathematics education classroom. She has been sitting in on a number of classes during the fall semester, and now this semester has been joining us to observe our Math 5941 class, which is using technology to teach mathematics. And she's going to present to you some of the work that she's done previously, and we are actually going to be building on that research work as a result of her being a part of this technology class. So I hope that you'll enjoy learning a little bit about this technology framework if you're not already familiar with it. And there will be some time at the end for questions about what she has done. So, go ahead. Thank you.
Thank you. Good afternoon. Today, I'll introduce the background, current situation, and the training strategies of TPAC for mathematics pre-service teachers, maybe in China. I'll introduce the content from 5 aspects below. First is the background. Now, the rapid development of information technology more and more deeply affects students' life, entertainment, and learning style. Annette Bruce suggests don't teach your students the way your teacher taught you. Maybe today teachers should teach students in a way that students like, teaching supported by technology. This way appears to be more effective. With the rapid application of new technology, such as mobile online learning, cloud computing, and big data in the field of education, educational informatization has become an unavoidable challenge to teachers' professional development. How to realize the deep integration of information technology and teaching has become the focus of researchers. Only when teachers understand how to integrate technology into teaching can they choose the appropriate technology to effectively represent the content in the teaching process, support their teaching activities, construct their own teaching design, and their own truly characteristic technology-based teaching. In the last decade, China has issued many policies and regulations, such as Outline of China's National Plan for Medium and Long-Term Education Reform and Development, Standards for information technology, application ability of primary and secondary school teachers, new education law of the People's Republic of China, and last year issued Education Informatization 2.0 Action Plan. All of these documents ensure and promote the formal implementation of national education informatization. According to the statistics, mathematics curriculum standards refers to the distribution of knowledge, points which can be effectively combined with information technology and mathematical experiment teaching, reaching over 60% in middle school and over 80% in high school. Now, information technology also as a new dimension of mathematics course and training. The characteristics of mathematics and its close relationship with computers make it possible for mathematics teaching to use technologies as tools. The truth and beauty of mathematics need to be expressed by computers. Mathematics in the process of recreation needs the support of technology. Chen Xingsheng, maybe you have heard him, a Chinese-American mathematician, said the immediate influence of computer is probably mathematics education. Some of the methods that used to be used need to be learned are no longer needed. At least they should be changed. This discussion is healthy for the development of mathematics. The development of computer technology has provided a new prospect for the development of mathematics education. Whether the social environment, the requirements of relevant policies, or the inherent close relationship between mathematics and technology, all put forward the requirements for the technology application of mathematics teachers. Fan Lianghuo points out that technology has affected that what to teach and how to teach. Teachers should include technical knowledge in their knowledge framework, where teachers' knowledge about technology includes the knowledge of technology itself and how to use technology in teaching. Technology itself does not help a teacher who don't understand students' learning. Only when teachers know how to use technology to promote students' thinking, expression, and knowledge construction can they have a positive impact on students' learning. Then I have some definition of core concepts. First is technology. Here, technology mainly refers to information communication technology, also is ICT, which is a new concept and technology field formed by the integration of information technology and communication technology, as well as the mainstream technology specially provided for mathematics classroom, mathematics calculation, and mathematics teaching and learning. TPAC is a framework which put forward from the perspective of teachers. It emphasizes the knowledge needed by teachers in the integration. It's a new definition of teachers' knowledge structure in the information technology era. Judith Harris pointed out that TPAC is the framework of teachers' knowledge. Therefore, it can help teachers plan their career development by clarifying the technology, pedagogy, content knowledge, and their relationships that teachers need to understand. This is the TPAC framework. It consists of 3 core elements, TK, PK, and CK, and 4 interactive elements interwoven by these 3 core elements, PCK, TCK, TPK, and TPACK. Maybe some teachers will think about why TPC consists of why TPAC is not TPCK. At the 9th Annual National Technology Leadership Summit, Misha et al. Consulted every educational association leader and magazine editor and renamed TPCK as TPAC because it's emphasizing that the three core elements of technology, pedagogy, and content are not independent. It's an individual organic whole, a total package of teachers' professional knowledge to help teachers use technology to promote students' learning. So they name the core of the framework TPCK as TPAC, TPACK. In most researches, the use of TPAC refers to the following two means. The first is to emphasize integrity. It refers to the TPAC framework, which contains 7 elements. The second, referring to one of the 7 elements. TPAC is a complex element formed by the intersection of technical knowledge, TK, PK, and CK. The third core concept is mathematics pre-service teachers. We also call them normal students. Here, we mainly refer to the pre-service teachers in the 6 directly affiliated normal universities of the Ministry of Education, the joint construction of the provincial normal university and the local normal colleges. Their majors belongs to the education with a 4-year school system. The future employment goal is relatively clear. That is, to all levels of schools or educational institutions to engage in teaching and teaching management is the preparation of future teachers. In China, pre-service teachers have a lot of preferential places. The central finance is responsible for arranging tuition and accommodation fees for them and granting subsidy. So they are free from study. However, after 4 years graduation, students must teach in primary and secondary schools for more than 6 years. So that's the reason why we have a lot of normal students. The cultivation of pre-service teachers should pay attention to both academic and pedagogical aspects. Academic refers to the special of subjects taught by teachers, and the pedagogical refers to the specialty of teachers' education. The common characteristics of mathematics normal students and other normal students is that they are normal nature, and the specialty of mathematics normal students is that their subject is mathematics. Now, there are a lot of researchers pay attention to the TPAC. So in China, through the China National Knowledge Internet, we searched the literature with the theme of TPAC or TPCK. As of September 20th, 2017, there were about 546 articles about education, teaching, and learning in total. Among them, there are 116 researches on TPAC of normal students or pre-service teachers, and 13 researches on TPAC of pre-service normal students or pre-service teachers. So it can be seen that the cultivation of TPAC of normal students or pre-service teacher is a hot topic. This graph is the number of articles about TPAC. You can see here is downside just because it's not a whole year. The research content is mainly focused on integration of information technology and course based on TPAC framework, knowledge framework, that is, applying TPAC theoretical framework to guide practical subject teaching and improve teachers' awareness of integration of information technology and the curriculum in practical work. The second is connotation of TPAC. It's focused on the understanding of TPAC framework, the development and application of related concepts. TPAC is the necessary knowledge for teachers to integrate technology into effective teaching. The third is focus on the TPAC training strategy, meaning for all kinds of teachers at all levels, focusing on how to improve the development level of teachers' TPAC, achieve the integration of TPAC knowledge and specific disciplines through the formulation of appropriate training strategy so as to achieve the goal of improving the effectiveness and efficiency of education and teaching. Then I have investigation and construct a structure equation model of pre-service teacher. First, in order to understand the current information-based teaching situation of elementary, middle and high school mathematics teacher in real classroom, a semi-constructed interview was constructed with them, hoping to play a guiding role in the cultivation of TPAC for mathematics pre-service teacher. The result of interviews with teachers are as follows. Most teachers often make a lesson using PowerPoint, Word, and mathematics teaching software such as Geometry, Sketchpad. It's also considered that mathematics teachers should be skilled in the operation and use of Geometry, Sketchpad, and should be familiar with the use of graphic calculator. Maybe until now, Chinese teachers not have much as American teachers software to use, because a lot of software we can't download or use directly. For example, PowerPoint is often used by a teacher to present the background of knowledge generation, visualize the abstract knowledge that students think, and help students improve their understanding of knowledge. Moreover, using graphic calculator, students can explore the process of knowledge occurrence by themselves, so that students can really understand the essence of knowledge. For example, this is a teacher teaching process. Suppose we have known 2 points, AB. Try to explore whether straight line AB passes through a fixed point. There are some steps. 1. In the geometry application of graphic calculator, we can define variable k to make straight line AB. By adjusting the slider, we can intuitively find that straight line AB passes through a certain point. on the negative half axis of y-axis. Then is theoretical calculation. Through the micro experiment just now, we can turn the equation of straight line into the form of y plus a equal to bx. Then we can seek the slope of AB first. After that, the equation of straight line AB can be written in the point slope form, like this. Then we can get the equation, and thus the straight line AB passes through the fixed point. One teacher thought that technology should be integrated into teaching, and the information technology should be regarded as the same teaching and learning tool as traditional tools such as blackboard and chalk, so as to realize the interaction between technology and the curriculum and promote students' comprehensive understanding of mathematical concepts and problems. By setting up mathematical experiments and incorporating abstract conclusions into them, students experience a process from concrete to abstract, which makes it possible to truly realize observing the real world with mathematical eyes, analyzing the world with mathematical thinking, and expressing the world with mathematical language. However, the most important thing is that our teachers should have TPAC, which is also the biggest challenge facing experimental teaching. As long as we continue in this way, we will reach the top of the pyramid of mathematical experimental teaching. Using the TPAC questionnaire compiled by Schmidt et al. For reference, after the analysis of reliability and validity, it is applied to pre-service teachers of mathematics. We can see the table. The result showed that the mean of 7 dimensions in TPAC was between 2.768 and 3.478, 3543. The lowest mean is TK, a little lower than the middle level. Here we use the 5-point scale. So the lower TK indicates that the technology knowledge level of mathematics pre-service teacher is not high and relatively weak in all knowledge structures. The possible reason is that our normal students, some of our normal students maybe come from not very rich, maybe economically difficult areas, and their school in middle and high school don't have too much technology for them to practice. The mean of TCK and TPK are higher, which indicates that they have experienced technology-based class in university now and have a positive attitude towards the integration of technology and feel more confident. The mean of TPAC is 3.478, which indicates that TPAC of mathematics pre-service teachers has a large space for improvement. Regression analysis of mathematics pre-service teachers shows that there were 3 variables with significant predictive power for TPAC among the 6 predictive variables. The standard regression equation is as follows. We can see only TPK, PCK, and TK in the equation. From the TPAC standard regression equation of mathematics pre-service teachers, we can see that they pay attention to the influence of TPK, PCK, and TK on TPAC. So we should help pre-service teacher enhance the lost TPAC connections. There are many factors affecting TPAC, mainly divided into internal factors, such as gender, skills, self-efficacy, attitudes, and external factors, such as hardware, facilities, curriculum, social values, etc. So we only consider internal and controllable factors. Here is the structural equation model I have constructed. This is the access, computer or technology access, such as it includes such as frequently convenient to use the computer or your frequency. This is the attitude to use the technology. This is the ICT skill ability, include basic operation and some special operation, such as some special software for mathematics. This is TPAC, include TPAC design, TPAC exertion, and TPAC proficiency. This is TPAC vocational self-efficacy, include professional values and relationships, and professional practice. According to the structural equation model, we conclude the prediction of TPAC by variables and prediction of TPAC vocational self-efficacy by variables. From the table, we can see that computer access has a direct and significant impact on ICT operation abilities. Pre-service teachers' technical ability level and their attitude towards the application of computers in teaching have a direct and significant positive impact on TPAC. TPAC and technology application attitude of pre-service teachers have direct and significant positive effect on their TPAC vocational self-efficacy. The analysis of the influence factor of TPAC of mathematics pre-service teachers shows that the ability of technical operation and positive attitude should be an important part in the training of TPAC. Last is TPAC development strategy. In China, it has been more than 20 years since the application of technology in mathematics teaching. Since 1995, Professor Wang Changpei has promoted the application of handheld technology in mathematics teaching. However, the incompatibility with the advanced, efficient, and practical digital educational instructor is the problem that the mathematics teacher's idea of applying educational technology is not strong and their ability is insufficient. So Dr. Zhang Jianyue, a scholar in China, put forward the idea of understanding technology. It includes understand the function of technology, understand the relation between technology and mathematics, and should rational selection of technology. How to train and develop teachers' TPAC becomes a problem that teacher educators have to face. By sorting out the development methods, paths, and specific strategies of TPAC, we can provide enlightenment and reference for the development of TPAC for teachers. First is reforming the content of education technology course. Teaching technology alone can't effectively integrate technology into teaching. Many researchers have reformed the related courses of educational technology and the teaching methods. American scholars also use TPAC as one of the theoretical bases in their compilation of the best-selling book, Integrating Educational Technology in Teaching, of American educational technology textbooks. The TPAC framework has entered the educational technology curriculum as an indicator. Second is the course model of combining theory with practice. Theoretical knowledge should be linked to practice so that pre-service teachers can understand the reasons for using information technology, such as these 3 steps. Accept of new information technology tools through teacher demonstration. Then establish technical proficiency. Then developing experience of technology integration through instructional design. Third is micro-teaching and case study. Pre-service teachers design a class around a special goal and in the form of group cooperation. Team members learn through 3 stages of cycle. 1. A group member teaches this lesson. A group member teaches this lesson in the way of micro-teaching. 2. Members watch and evaluate the video together. 3. Modify it together, so that experience the development of TPAC in viewing, discussing, evaluating, through evaluating and revising and reflecting so that pre-service teachers' TPAC can be improved. The last one is peer coaching. It's group learning in the application of information technology. Our students also, our pre-service teachers also has a lot of practice. Every year we have the pre-service teachers teaching ability competition. It includes teaching ability, writing such as this one. It need the blackboard, knitting, beautiful, maybe like this. To competition their writing, and also they have the practice in a group. This is group teaching. One pre-service teacher teach on the platform, and their classmates will be as students. After that, they will change rules to teach. So after several cycles, some students can be more confident and more proficiency in their teaching. So that's all. Thank you.
Questions? I know my TPAC students have questions.